Okay, Assalamualaikum warahmatullahi wabarakatuh, and have a good day to everybody. So now we are continue our study in the static in the second chapter. So we have done the first chapter, the basic principle in static, and also what is the introduction, what is the mechanics. So mechanics, we have the two areas, static and dynamics. So it's actually in mechanics area is we have we have the mechanics, we have the rigid body, we have the deformable body, we have the fluid mechanics. So in the rigid body mechanics, we have the two areas, static and dynamics. So now we are moved to the second chapter. Is a force vector. Force vector is very important. I really need your you give the full attention in this chapter, force vector. I will give you many exercises, many problems you need to do, and exercises, all my exercises, which is it's actually is very important because we need to have the basic reduction calculation for all the remaining chapter by using this force vector. Okay, the objective in this chapter, I don't want to make too many objective for where we learn. It's because we need to really to understand what's actually the force vector. So the objective here, we need to understand, be able to draw and then using the parallelogram law and also the Cartesian vector form. So by the outline from these two objectives, can divide it by to the six topic in the simple, not too heavy each topic. So we need to understand what is a scalar, what is a vector. So we need to understand, we need to operate how the vector can be add, how the vector can be subtract or multiplication, what is the vector operation, and also what is the coplanar forces. So the vector can be breaking into the x and y axis. So how you want to express the vector, what is the units of the vector by using Cartesian vector. So from the Cartesian vector, so we can add and subtract. If let's say we have the two forces applied at one point, for example, we have the more than two forces, how you want to get the final resultant of these two, all these forces. So the first topic, we need to understand what's actually scalar and vector. I think you have learned. You can already find these scalars and definition vector in your physics. I just want to refresh back. I think the scalar is actually the magnitude, the quantity that is described as a have the magnitude only. So either positive or negative number. So let's say the mass, volume, and the length is a scalar. Yeah, how to indicate by letter is actually in this we are using the computer, we can put as italic, but if you are right in your paper, it's just a normal letter. Okay, for the vector, is actually the quantity is actually described by the magnitude and direction. So instead of we have the magnitude, we need to also have the direction. So that's a vector. The difference of vector and scalar, we just have the direction for the vector. So for example, position, force, and moment has the magnitude and also have the direction. So in the how do you want to represent, how we want to differentiate what is a scalar and what is a vector, so we just put arrow on top of the letter. So magnitude of the designated and the vector is just put, we have put the absolute, we have the bar here. How to get this magnitude of the vector. In this subject, the vector is represented as the bold. We can bold A, and by the magnitude as a no, they have no bold at A, the letter without bold, and then as a letter with bold. So it's using computer, but you just write in your paper, just put the arrow on top of the letter. Okay, we can see here okay, we can see here the force or the vector. This one is the magnitude, the length of the vector is the magnitude, but we have the direction and angle. So this vector, for example, this is length. The length is magnitude, but we have the angle. Angle is the direction. So normally the direction is calculated on the positive x, from here, from 0 to this point. So this actually the angle. Angle means the direction of the vector step. Okay. So how you want to, for example, we want to do some operation into the vector. So we have we can multiply, we can divide, we can add, we can subtract. So for example, we had a multiplication division of the vector by a scalar. For example, we had a vector E here. If you want to multiply by a scalar 2, you just double the same direction, but the magnitude become twice the length, to double E multiplied by 2. So product of E and scalar E, so the product is just E multiplied by the vectors, become the 2E or the EE. The magnitude of this one is the, we can put the this absolute. Okay, the law of multiplication applies. For example, E, the vector divided by E. Essentially, when we can see here is a division essentially, but essentially 1 over E is multiplied by E. The same thing. 1 divided by E, just multiply by E. It's a multiplication, but this one is a division. So here is the magnitude A just multiplied by a negative 1, so just opposite direction, then dividing by 2 here. Okay, for the addition, so addition vector, we can add two different vector A and B, for example. So how you want to add these two vector? By using the parallelogram law. So when we add these two vector, so we come out a resultant force R. So from this R, so actually we can put in the upper triangle or lower triangle. So this A and then this one is parallel to A, this B is parallel to B. So let's say we put take the upper triangle. So the vector R, resultant vector R, is actually equal to the vector A plus dengan vector B. So A plus B, or vector B plus dengan vector A. So R is equal to A plus B, or equal to B plus A. This one is a vector, not magnitude. So vector A and B are collinear. For example, when both have the same line of action. For example, from this point to this point is a vector A, from this point to this point is a vector B. So the resultant force of these two vectors, or not resultant force, resultant vectors of these two vectors from here to final point of B. So actually R is equal to A plus B. So addition of collinear vector. Then how I want to subtract? I want to subtract the vector. For example, the A and B. So whereby the B is actually, you want to subtract A minus B, we can put the direction opposite. For example, B, if you put minus B, so actually you focus on minus B is negative B. Instead of the B is actually from to the right, so now negative B is a negative direction. So negative is the opposite direction. So A plus negative B. So we get the resultant force here. So rule of vector addition apply here. So actually A plus dengan negative B is equal to resultant vector R here. Okay, so now how you want to find the resultant force? By using the vector addition of forces. So we have the parallelogram law, as I said in the objective before this. So we can find the resultant force by using the parallelogram law to carry out to find the resultant force. So force 1 and force 2 is subjected to this hinge. This is the wall. So how you want to get the direction of this hinge? Either is move out, or if the, let's say it's a move out from the wall. So how is the direction? Is follow F1 or follow F2, or go to another S of direction. Okay, so how I want to get this the resultant force or resultant direction of this hinge? So we can add F1 and F2 by using parallelogram law. So parallelogram law is actually, we want to draw up the rhombus. For example, here it's a parallel of these two forces. So we take the parallel of the F1. So the tail of the F1 we put this one is the parallel of the F1. The tail put the head of the F2. So this one is become the parallel of the F1. So parallel of F2 is here. So the tail put the head of F1. So we can have this one is the parallel of F1. This one parallel of F2. So you can draw up the triangle, the diagonal line from here to here. So the resultant force here then we can take the upper triangle, lower triangle for the trigonometry the triangle construction. So resultant force is equal to F1 here plus dengan F2 here. So resultant force meaning by the F1 vector plus F2 vector. Okay, I think we can stop here. We can we continue later inshallah in the other session. Okay, see you. Thank you for your attention. Bye bye. See you again.